Okay, next, I wanted to talk about the Dabble part of Double Dabble. Okay, and so the goal here is to make our results show up in BCD. All right, eventually we want to represent a binary number from the switches or some register, and we want to be able to convert that to a BCD representation so that we can take that to the 7-segment decoders and end up showing what that result would be in decimal. All right, so the Dabble technique applies, and the overall goal here is we want to multiply digits 0 through 9 by 2 because of the doubling method, and represent that result in binary coded decimal, BCD. All right, so let's get started. All right, for the very first four numbers, 0 through 4, we don't have an issue. That works out pretty easy because BCD and hex correspond for the first four of these. All right, so let's take the upper value of the range, which is 4. All right, so 4 times 2 is 8. If I convert 8 to hex, 8 in hex is also BCD 8. So we're good. That's the biggest number in that interval, and so everything's going to work out for all the numbers between 0 and 4. All right, so next, let's talk about the range 5 through 9. And what I'm trying to do is I want to take that number, double it, and then represent that answer, that decimal answer in BCD. Okay, so let's get started. 5 times 2 in decimal, that's 10. All right, so the trick here for Dabble, the Dabble means that you're going to take a look at the number that you're trying to convert. If that number is 5 or greater, you're going to add 3 to it before you do the double. All right, so when I add 3 to that, 5 plus 3 is equal to 8. All right, in other words, just another explanation to think about, 2 times 3 is 6, right? And so what we want to have happen is we want to carry out into the next 4 digits anytime we get a number that carries over in the decimal digits. So if I add 6, if I had 10 and I added 6, it would carry on over into the next 4 bits. All right, so that's the trick. They talk about that in the book if you'd like to read about it. But you'll see how it works. 5 plus 3 is 8 times 2 is 16 in decimal. All right, if I take 16 and I convert it to binary, in binary that would be this, and then notice this is BCD 10. So that's the goal. BCD 10 matches decimal 10. All right, so that was the result of the Dabble. Okay, and so we can do the rest of these. 6 times 2 is 12. All right, 6 is greater than 5, so I add 3 to it before I double. 6 times 3 is 18. 18 in decimal turns out to be 16 plus 2 in hex. All right, and then if I convert that, if I look at that as a BCD interpretation, that would be BCD 12, which, that was my goal. I wanted this decimal multiplication to be represented in BCD. All right, so you can go through all the combinations. 7 times 2 is 14. 7 plus 3, because 7 is greater than 5, or greater than 4. Greater than or equal to 5, or strictly greater than 4. So 7 times 3 times 2. 7 plus 3 is 10, times 2 is 20. Convert that, 16 plus 4, that's BCD 14. All right, so I've done the rest of these. You can take a look and convince yourself that this is performing this statement. Multiply digits 0 through 9 by 2 and represent the result in BCD. For the first 4 digits, 0 through 4, we don't have to do the add 3 trick. For things 5 through 9, we do have to do the add 3 trick. Okay, so next I want you to think about that in terms of a circuit. All right, remember our goal, we've talked about this in class, is we want to be able to visualize how we do things, that maybe have a mathematical representation, how that ends up working out in circuits. All right, so I know I have this add 3 circuit. All right, so the very first thing that I can highlight here, get a different color, let's do gold, is I put 3 to one of the inputs of the adder. All right, and then I have the number that I'm trying to represent. It's, the idea here is these are the normal digits that we look at, all right, 0 through 9. All right, so that's N, okay? And I'm going to go ahead and add these together no matter what, all right, and get this quantity that I call N plus 3, all right? And this will work for things in the range of 0 through 9, okay? So this signal is N plus 3. All right, then we've talked about in class a comparator circuit, so I'm going to compare N with 5, all right? And if N is bigger than 5, I'm going to put that into a multiplexer with the select line, okay? So if N is bigger than 5, we're going to select the path that has N plus 3, and that would go to the output, all right? If we had a smaller number, all right, so let me get rid of that. If we had a smaller number, if we had, say, for example, N was equal to 3, okay, then this signal coming out would be a 0, and we'd select the 0 line, and N would go on through the output. All right, so you can envision the Dabble circuit, and we're going to put this all together in the next video to do a double Dabble algorithm.